there will be 2 proofs on the test, and both of them are fill in the blank. I expect you guys to get all, and maybe even start off first, of the givens. And so the given in the problem, I won't say given on the test, but it'll definitely be in an area where you can tell it is given. So here is given, and also, whoops, here. So always, always, always go through, do that first. You should always get a few points on these. Okay, and then the last thing you should always get correct too is, what are we trying to prove? Right, let's make that a different color. What are we trying to prove? Because that is always going to be the last statement that we make. Remember, statements and reasons, the same as claims and evidence. So here, what we're trying to prove is that triangle ONP is congruent to triangle PQO. Okay, in this figure over here to the right. So I've already gotten 3 points. I only need 3 points left. I'm already halfway through this problem. So I know that N and Q are right angles. So I'm going to find them, and I'm going to put a right angle there. Okay, that's given. And that means that I know that triangle ONP and triangle PQO are right triangles because of the definition of a triangle, right? That has 90 degrees. Now this next one I want you to remember is the reflexive property. The reflexive property always has to do with something being equal to itself. So in this case, I'm going to look at this figure over here, and I'm going to see what could possibly be equal to itself that both of those triangles share, and obviously it's going to be this diagonal here, OP. So we're going to put in there, because of reflexive property, line segment OP is obviously congruent to itself. There you go. We are down with OP. Okay. And then last, okay, so that's reflective property. So we know that that's equal to itself. We know that these angles are equal to each other. Now we know that NO is congruent to PQ. That is given in the problem. So how do we know that triangle ONP is congruent to triangle PQO? All right, so for this particular one, since angle, or side angle is not a thing, I am just going to say, because it's a right triangle, they have that special congruency called the hypotenuse and the legs of one hypotenuse and one leg of a right triangle, and they call it the HL on page 74 of your book. Okay, so this is why it's really important to have these notes for the test. That is the reason why we can say that these two triangles are congruent. Let's try this next one. So I like to go through first and make sure that I can get the questions, the easy questions. I know ST is parallel to RU. There, that one's going to be given, and SR is parallel to TU. So this is also given. And then what am I trying to prove? That triangle SRT is congruent to triangle UTR. So that's going to go there. Triangle SRT is congruent to triangle UTR. That's what we're trying to prove. So that's, let's do this. So triangle SRT is congruent to UTR. Yep, so we see our two triangles. Let's get everything that we can in there, given. All right, so I think that this particular proof is actually trying to do too much, but I think it wants you to see that you could use either one of those parallel sides. So just check here, because both of these angles, SRT, we know because parallel lines or alternate interior angles are congruent. And we know both sides are parallel. What we end up knowing is that obviously these are alternate interior, and also these are alternate interior, but you could have done it with either side. but you didn't need to do it with both as this proof does, but you definitely can. So it already has SRT and UTR. So just really quickly, let's figure out what that one is because we will want to do the rest of them. So it has SRT this way, and it has UTR. Okay, so that was that angle. They use that angle here where the star was. So the angle we're going to use here will be the other one, which is, and we have to do it in the correct order, TRU. TRU. Angle TRU is congruent to angle STR. Okay, but we could have figured out 2 and 4 using just one of the parallel sides. We technically didn't need to put both of those parallel sides in there. But this number 4 is just the same as number 2. So I don't want to write that down, so I'll just do same as 2. All right, so we know that they have 2 angles in common. Oh, I know. We need that side, and we could do angle, side, angle. And we know that RT is congruent. Whoops. We know that RT segment is congruent to itself, and we know that because of reflexive property. And then we know that triangle SRT is congruent to UTR because what did I just say? Angle, because of angle, side, angle, congruency theorem. Okay, so don't forget you should always get 2 or 3 or even 4 correct in these proofs because of the givens and what you need to prove.